In section 7.2, we're going to talk about similar polygons. And the definition of a similar polygon are figures that are the same shape but not necessarily the same size. Those are similar figures. So if we look at these two triangles below, if I label them, I'm going to put ABC on this triangle and say each side is 7, and then DEF on this triangle, and each side is 2. They are similar triangles because they are the same shape, they're both triangles, and all three sides are the same when looking at each triangle individually. So AC is not the same as EF. AC is 7, EF is 2, but they are similar triangles. So our symbol for similar is kind of like congruent, but we only have one little squiggle. So congruent looks like this. That means they are equal. This little squiggle just means similar. Okay? Now you could have two triangles if we had ones that looked like this. If this was a right triangle and we had this triangle was not a right triangle, these are not similar. Even though they are both triangles, they are not the same exact shape. Okay, so let's look at some examples. Complete the similarity statement for this pair of figures, and we need to draw the pair of figures. So if I drew a shape like this, and one like this, I'm going to call B, A, C, D, G, F, E, H. Okay, so if these two figures are similar, we want to write all the sides that are similar to each other. So if we look, we know AB is our slanted one, and FE is our slanted one on this side. So that means AB is going to be similar to FE. Then going from there, the small side at the top, BC, is going to be similar to FG. Okay, and these are all segments, so I'm going to put our segment label on top. Then keep going down, we have CD along the side, and that is going to be similar to GH. And the last side we have is AD and EH. Okay, so those are all of our similar sides. For our angles, if we look at the angle with the slanted side, that matches angle E. When we have similar figures, our angles are going to still be congruent. So angle A is going to be congruent to angle E. And that's because inside of our figure, no matter how big it is, we're always going to have the same number of degrees inside of that figure. So that's why our angles are the same, but our sides are similar. Okay, so then going from those angles, we have this corner angle, angle D, and that is going to be similar to angle H. So it is congruent in this case. Then going up, we have angle C up here, congruent to angle G. And our last angle, angle B, so if I draw 4 lines in here, that is going to be congruent to angle F. Okay, so if I want to write overall that my figure ABCD is similar to my other figure, I need to make sure those angles line up. So A matches E, B matches F, C matches G, and D matches H. Okay, and you can write those in any order as long as they match up. So I could have started with B first, so long as those match up. Okay, like I just mentioned, facts about similar figures, corresponding angles are congruent. So we have our congruent symbol, and corresponding sides are similar or proportional. Or similar. Okay, so the reason I'm using that word proportional, we just talked about proportions in 7.1. Now we're going to look at an example where we're going to have to use proportions to figure out if our triangles are similar or not. So I'm going to give our given information here. I'm going to say this side's 12.8. Got 6 and 14. And then this angle is 25 and 65. Okay, then over here we have Y, 7, we have points D, E, and F, and X. Okay, with this information, we're given our triangles are similar, and we want to find what's missing. So, first of all, EF is our X right here. Oops. And we want to figure out what that X is. So to do that, we need to set up a proportion. So EF is similar to BC on this side. So if I write a proportion, EF is X over BC, which is 6, is equal to, now I need to pick two other sides of my triangle I can compare it to. Well, I know this side here is 7. And since I put the X on top, my small triangle is on top. That means my 7 is going to go on top on this side. That 7 is similar to my 14, my AC on the other side. So my big triangle numbers are on the bottom. I've got 6 and 14, both on the bottom of my fractions. Now that I have that set up, I can cross multiply. 6 times 7 equals 14x. 6 times 7 gives me 42. When I divide by 14, I get x is equal to 3. So that means EF is 3. Then when I'm looking for DE, I can set up a similar proportion. So I have Y this time. Y is going to be similar to this side, 12.8. And I can use this same ratio over here. I've got my small triangle on top, big triangle on the bottom. Cross multiply, I get 12.8 times 7 is equal to 14x. Sorry, Y this time. Okay, so 12.8 times 7, that gives me 89.6. Divide by 14, I get 6.4 is equal to Y. Okay, so I have my sides figured out here. Now the easy part in similar triangles or figures is finding the angles, because if I know that this angle over here is 25 and it's similar to this angle right here, then D is going to be 25 because corresponding angles are congruent. Fact number 1 at the top here. If our angles are corresponding, then they're going to be the same. So same thing for F. Looking for F, it's similar to C, which is 65. So angle F is 65. Now, something else that we're going to be talking about with similar figures is a scale factor. A scale factor is the number that I have to multiply a side by to get my other side. So, if you think about it, this big triangle is about twice as big as this small triangle. So if we look at that comparison, if we have a ratio of the small side to the big side, or the big side to the small side, we would get, let me just get my pen here. We've got 14 on our big triangle and 7 on our small triangle. Those two sides, those are our ratios we're setting up. If I simplify this ratio, 14 divided by 7, I get 2. That 2 is my scale factor. No matter what side I picked, if I picked 6 and x, which is 3, 6 over 3, that equals 2. My scale factor is going to be 2 no matter which sides I picked. So that scale factor tells me how big those triangles are related to each other. This tells me the big one is twice as big as the small one. Okay, let's look at one more example. Our last one, I'm going to draw our figure again. So we start with four-sided figure this time that looks like this, and a larger one like this. Put some information on here, RSTU, DEFG. We've got 75 in the corner, 120 for S, 12 and 12, 8, 16, and that's it. So I know that these two figures are similar from my given information up here. I'm looking for the scale factor of my polygon RSTU to polygon DEFG. Now I can use any sides I want to find that scale factor because remember, if they're similar, the scale factor should be the same no matter what sides you pick. So I'm going to pick two sides that I know from both. So I have this side here, 16, and this side here, 12. Now it wants RSTU first, so that means 12 is going to be on top and 16 on the bottom. When I simplify that, I get 3/4. Okay, next it's saying the scale factor of DEFG to RSTU. Now I'm doing the same thing, but this time I'm going to put my value for DEFG on top, which was 16 over 12. So now when I simplify, I get 4/3. If you notice, that's the same thing I got over here, just the reciprocal. So this is saying that RSTU is 3/4 as big as DEFG, or DEFG is 4/3 as big as RSTU. Okay, so now if I'm looking for C, measure of angle E, I know that S right here is 120, and S and E are similar, so that means E is also 120. Same thing with G. I can find G easily because I know U is 75. Now for E, I'm looking for RU, this side right here. Well, I already know I have one ratio. I have my 12 over 16, and here I'm putting RSTU on top and DEFG on bottom. So when I set this up for RU, I'm going to compare that with DG. So that 8 is going to go on the bottom, it's DG, and this is my RU. That's what I'm solving for. So I'm going to cross multiply. 16x is equal to 12 times 8, which is 96. Divide by both sides by 16, I get x equals 6. So that is my value for RU. Okay, now I'm going to find EF, and I'm going to do the same thing. I'm going to start with my ratio that I know, which was 12 over 16. And again, I've got that RSTU on top and DEFG on the bottom. Okay, if I have EF, that is my DEFG, so that is my Y, I'm going to call it this time, so I don't know what that is. And that side is going to be similar to ST, which over here is 12. that means I'm going to put a 12 on the top over here. Now, looking at this right away, if I have 12 on top of both of those fractions, the only number that y can be is 16 if they're going to equal to each other. But if you want to check, you get 16 times 12 is 192. It's equal to 12y. Divide by 12 on both sides, and you get y equals 16, which is EF. Okay? These last two questions, G and F, they are asking for the ratio of the RU to DG. Now, we know what those are, RU and DG. They are 6 over 8. And if we simplify that, we get 3/4. Which, if we look up here, that's what we should have gotten. The ratio of the figure RSTU to DEFG is always going to be 3/4. So to find H, even though we don't have FG right here, we don't have FG and UT, we still know what those ratios are because the ratio of DEFG to RSTU, no matter what sides we pick, is always going to be 4/3. That's what we got here for B.